السلام عليكم ورحمة الله تعالى وبركاته. نرحب بالجميع ونيابة عن سجر الخليج. نواصل سلسلة الويبينارز، والآن نحن في الويبينار الثالث، ونترك الفرصة للدكتور رمزي جديم من شركة المختبر الخليجي للتعريف بنفسه وتقديم عرضه إن شاء الله.
السلام عليكم. The title of this webinar will be Transformer Diagnosis Method using Oil Analysis. We will focus on oil analysis in this presentation. My name is Dr. Ramzi Jadim. I have PhD from Sweden, especially in technology, which is the transformer maintenance. And I am working as technical consultant with GCC Lab, Saudi Arabia. There is some noise, I see. There is noise coming. Yes.
I think everybody should be on mute so that you can hear.
Yeah. I think there is one should be.
Hi, Dr. Ramzi.
One minute, please. I want just to record the. Okay. The presentation will take around 1 hour or 15 minutes, 1 hour and 2 minutes around this one, and then I will keep the for the any question or discussion later. Okay, now from here.
Now
okay.
It's clear, I think. Yep.
Yes. I will talk first about the strategy, maintenance strategies, which used in the normal use, but also I will talk about the new strategy for maintenance. Usually, as a normal, there is a preventive maintenance and there is a breakdown maintenance. Breakdown maintenance, usually they do it after failures. Preventive maintenance, that there's two parts of preventive maintenance. One is without fault investigation. It's called predetermined maintenance. Predetermined maintenance you by the time, every 3 years, and they not consider the fault investigation or something like this. The with fault investigation, which is very important, is usually used now in most of the transformer maintenance. It's condition-based maintenance. This one based on the condition monitoring, which is such as oil analysis, electrical testing, and also inspection. But primary condition monitoring, it is the oil analysis to evaluate the condition of the transformer. Condition of the oil, of course, it will give me condition of the transformer. And after oil analysis and the other testing, it will be condition assessment to the transformer if there is any fault, evaluation of the or interpretation of the results. If there is no fault, so in this case, it will back again, 6 months, 1 year, according to the plan, maintenance plan of the power plant. But if there is fault, that meaning maintenance action should be taken to correct the to correct any issue before development to a big problem. And also it's very important, the process evaluation after this one, to see what's the gap, where is the gap, where is the good things that should be taken, and something like this. This one is published, one of my articles. I have many articles regarding the transformer maintenance, and this is one of my articles is written here. Oh, by the way, if anyone need my articles, I can send to him, or I can give him the link for this one later. The new maintenance, it is called sustainable maintenance. It's a proactive maintenance that ensures sustainability in all stages of the transformer life cycle. It's not just for economy, it's also coming for social, for environment, is to take care about this one also. Environment, we must consider that to reduce pollution and emission and hazard waste, we must take care about this one. We must account these things to protect the environment. And also for social, try to be less accident, safety work, avoid risk for the people working there. Also, the very important that to give sustainable energy to the society. This is very important. And of course, customer certification for power plant. These things I focused, or we group focused on this sustainable maintenance, and we publish some articles about this one also, how to apply the sustainable maintenance. Of course, the economy, the normal, lower maintenance cost, less expensive employee, and the other things. This is the new development of sustainable maintenance. We used for sustainable maintenance, we did some case study. It was in Kuwait plan, I think 2017 or something like this, 18. And we took around 972 transformers. And we did scanner for all types of faults, from gas faults, from partial discharge, arcing, oxidation, corrosion, all types of, we studied all the types of faults. And we found that they have many faults here. But the most important, we consider this already there, the one already there were the fault, but we focused on starting the fault here. How we can stop the process of her, so it's not coming to be a critical case or critical situation. And we studied this one, and we applied the sustainable maintenance tools, and it take around 2 years from us to finish this project. What we use in this one, or what the very important things here to keep your transformer sustainable, or to keep sustainable energy from your transformer. This one, I will come back to this later after some slides to explain what we did in this case. And of course, we in that time we reserve around 70%, is around 60 or 50, 60 transformers. I think we gave them the corrective action to do it, to avoid that. I will talk a little about the components related to the oil analysis, which is related to the oil analysis. The most important here, it is the winding. Winding or the paper, insulating paper is the heart of the transformer. So the first, which is exposed to the any issue in the oil, insulating oil, it is the paper here. If there is overheating or arcing or partial discharge, the effect it's by the mostly on the paper. We have another things also, some indicator. Here we can see it is the Buchlas relay. Buchlas relay, usually it is here between the conservator and the tank. This one, if there is any problem in the oil, that example, high pressure of the gases coming up or gas bubbles coming up, in this case, the gas, it will be captured here. But the problem that if exceeds some level of the gas pressure here or gas level, so it will trip. And this one, of course, is a problem if a trip coming from this side. We have also pressure relief valves. It is in the upper side. It's coming here, the upper side. This one also affected by the gases from the oil. If too much pressure coming from the partial pressure coming from the gases, it will also this one will give alarm. But the problem that also this one, it go direct to the trip, the transformer direct. And there is another relay is called sudden pressure relay. This one, especially if there is any arcing, this will be sensitive to the arcing, partial discharge and arcing. And there is also another thing related to the oil. It is cable boxes. Also, it is very important to be checked the oil analysis to see if there is any gases, if there is any problem inside it. Many trips it was from the cable box also. All this one related to the oil analysis that we must focus on it. Also, there is another one. It is tap changer. The oil inside tap changer. Usually this tap changer in the vessel, and this vessel it's with the oil. And this one is very important also to check the oil of and if there is any leak between the tap changer and the tank. Also, this can be indicated by the oil analysis. Overheating in transformers. The most issue is coming from the overheat, of course. But what the source expected from the overheating? We can start with copper energy loss. Skin effect is called. This one, the winding is from the copper, and usually from in the middle of and the inside the copper from the middle, it's the hottest area. Then, if there is any problem in the load or in the increase the currents and the winding, it will be diffused to the outside of the copper. It's coming to the paper like this. If we go back to this one here, if it is diffused outside, so it will affect on the paper. That is very important. It will be damage the paper. Core loss, eddy current. Core loss, usually there's circulation in the magnetic circulation current in the core, and this one, if it is not manufacturing, elimination is not very good manufactured. Also, this can escape some currents outside, and this one increase the overheating, or can be source of overheating. Cooling system fault also. It's very important for the cooling system to be in correct situation correct must be checked. I was in Oman one time, and the problem that they have all the times they have overheating, and everything is okay with them. There is nothing, and the transformer was a new one, and all the times they have overheating problem. In that time we were there in the summer, July, and we see that they use for two things problem we found there, that they use the automatic cooling system that in special temperature they open and close. And this one we told them that in the weather here in the Middle East is very high in the summer, so keep it open all the time. And also we found that some of the was not work correct, some of the fans. So this one must be also, it can be the outside ambient temperature can increase the temperature inside the transformer. Load percentage. According to the one article, this is not my article, there's one article, they found that the operation at only 10 degrees above the transformer rating will cut transformer life by 50%. So keep the loading in the normal level is very important. Oxidation deposit, that the oxidation reaction, the inside the transformer coming due to overheating, that this one can be also give more temperature inside transformer. Corrosion deposit. Why these two deposits is very important to be very careful about this one. That this one, it will deposit on the winding, and it will be no exchange heating between the winding and the oil, because oil, one function of the oil is cooling the system, that exchange the heat to the outside. And also this, of course, coming partial discharge, arcing, and other many things that can affect to the overheating. So we will try to study most of this one and try to avoid this problem by oil analysis. We will see there is something, evaluation condition for the, I'm talking about oil analysis. It is, we focus about mostly four main aspects. The first one is combustible gas generation. This one is very important. It's called the dissolved gas analysis. Here to check the analysis, very, very important. This most of the in the Europe. I worked in the Sweden before, and we do every 6 months DGA. If it is normal, we do it 6 months. If it is abnormal sort, we will see about the maybe every 3 months, something like this. And sometimes they use online. In many transformers, they use online DGA on-site the transformer, and they give they can take the gases every 1 hour for the transformer, suspected transformer. We will talk about this one in detail, and then I will talk about the paper degradation. Number 2, the paper is the heart of the transformer insulating paper. And so how we can, what oil analysis you need it for evaluate the paper of the transformer. Oxidation deposit, we will talk about this one. Corrosion deposit, and there is something others also affect on the condition of the transformer. I will start with the combustible gas generation, or call this DGA, dissolved gas analysis. Usually the oil is hydrocarbon, from carbon and hydrogen mainly. And if there is any overheating or plus oxygen, of course. And also the most important here also to check the oxygen inside transformer, not just overheating. Oxygen is the enemy of the transformer. In this system, in this the gas in this situation, the gas will generate is hydrogen, methane, ethane, ethylene, acetylene, carbon monoxide. All this gases is called combustible gases. And of course, there is carbon dioxide and oxygen, nitrogen also. This is very important. Oxygen and nitrogen. The important that here we see usually there is a special ratio between them, but if we see there is degrees in the oxygen values, that means some oxygen already used in the fragmentation of the oil. CO also is this carbon monoxide also. It gives me information about the paper. I will come to this later. So each gas here give me indication for something. I will talk about this one now. If we see the most hydrogen, main hydrogen, methane, ethane, ethene, acetylene. In the normal condition, it's very low, but increasing if see this hydrogen is starting and methane starting here as around 200 degrees, and then 250 it will be start the ethane. So the value of each that there is a problem issue that the temperature is very high in some level. And if you see here at 300, it's coming the others. At 350 start the ethene, and then acetylene in the yellow, and hydrogen. Actually the most important is two. Hydrogen, high hydrogen and high acetylene. That's meaning it's because it's coming is at very high temperature, and that meaning possibility of arcing fault. If I found this, and also I found that there is the other is very low or nothing, just hydrogen and acetylene over Quotient limit. That means we have arcing fault. And if there is just hydrogen without any other gas or a little from another gas, and the hydrogen extremely high, that means we have partial discharge. That means we are here. We are here in this area. This area is partial discharge. This area is arcing. This area is partial discharge. Without any acetylene, just a little acetylene is partial discharge. If I have just these three, if I have just from this area, that means I am in the thermal fault between 200, 300 degrees. This one is very important information that we give it to the transformer owner. Usually, if we found extremely high gases in the transformer and we have no historical data, usually we tell him that make fault investigation. But if you find just a little over Quotient limit, we will tell them that if he can bring the new gas sample, new sample for DGA after 1 week or after 1 month, according to the situation of transform. Then we will calculate the ratio, the generation of the gas per day or per month. Usually, if we come per day, if it is coming more than 0.3% per day, that meaning there is a real issue, real situation, and they should critical situation, and they should take action about this one. Direct, they should take action. This gives information about how it's important of oil analysis and the transformer life assessment. I talked about partial discharge, arcing, but here I will give some definition for some maybe from our view that partial discharge is a small electrical spark that occur within the electrical insulation system. Sometimes it's called spark over. If it is coming through the oil, if it's coming through the insulation paper or something, it's called puncture. If the surface of the solid insulation, call it flash over. This is some just name of this one, maybe hear about this one. I will show you the flash, the partial discharge video here. How can I see the video here? Okay. Now, if I go there, you can see how it is. Maybe it's very fast. I will try to give it again. See, it's starting like this. Cannot stop it. If you see, it is started, but it's very fast. Anyway, it's started between two bubbles, two gas bubbles, and then between them there's a void. And between these two bubbles, if it is oil, is insulation of the oil is very bad due to the aging, due to the oxidation product, something like this. So it catch the fire rapidly, very fast. If I see it here, I cannot stop with this. See between them here. Yes, see the link between them start, then it's coming the temperature. The temperature of oil surrounding this area, it's coming around more than 1,000 degrees centigrade, but it's very short, microsecond of very short. But if it is coming more of flashing like this, so in the total, and if the oil insulating system in the oil is very bad, so sure you will get fire or failure in the transformer. What can be a consequence of the partial discharge like this? It's formation of hydrogen gas. And therefore, said on the slide before that, if there is too much hydrogen, extremely high, that means you have a partial discharge. And what's the solution for this one? Usually there is they should the electrical or mechanical electrical engineer there in the power plant, they should check there is a partial discharge device or apparatus that to check if you have or where the location of the partial discharge, and try to solve the problem before it be developed to a critical situation. Hydrocarbon cracking and corona discharge. Because this one give me another, partial discharge give me another problem. It's called corona discharge. I will talk about this one in the slide after. polymerization of saturated hydrocarbon. The oil viscosity, they have viscosity, I think should be around should be more than 135 degrees centigrade. If it is more partial discharge like this, the oil it will be heavy, polymerized, it will be heavy. And why, if it is heavy like this, we will get a problem that circulation of the oil in the transformer will affect it. So the cooling system will affect about this. Formation of gas bubbles also. This one give me more gas bubbles. And in this case, we must calculate also should be calculate the gas, the possibility of the oil to form gas bubbles. This one, it can be calculated, can be. Complete breakdown of oil at around 1,500 to 3,000 degrees. It's called arcing, high voltage discharge. Arcing is a high voltage discharge. So in a critical case, of course, it will cause fire or failures, something like this. We'll talk a little about what's meaning corona's discharge. It's a partial discharge of low ionization density, which occurs in a gas cavity in the insulation. How can be like this? If you take hydrocarbon meaning the oil here. Here it is the oil. Oil. And if you see, if there is a partial discharge affected for the oil, like what we see in the video, what can the hydrocarbon can, some of it can give me electron, and it's called ionic hydrocarbons. What's happened if you have electron inside transformer? It can attack any solid area. Can be on the core, or can be in any conduct inside the transformer. And then also they give me a charge here. And then this one, it will be converted to hydrocarbons, and then hydrocarbons give me electron, and this circulation all the times. This circulation give me all the times flush. This is called negative corona's discharge. The positive corona, the negative corona discharge, that's the ion of the oil can attack also, not just electron, attack the solid component, and then give me electron, and electron coming here, and it will be circulation all the times. So we need to avoid this problem. What you need for oil analysis test or testing the oil to avoid these problems, you need to do, of course, all the gases, to check the gases concentrations, and also you need to see the total compositable gases. And there is also, maybe it's not written here, the equilibrium gas pressure is not written here. Equilibrium gas pressure, this one give me information if your oil, it's the ability of your oil to create gas bubbles based on the gases concentration, and also based on the aromatic of the oil. Also, you need to do stray gases or stray gassing. Stray gassing that we or in the laboratory, they take the syringe of the gas and keep it in the very high temperature for 1 week, and see the gases before and after, to see the capability of your gas capability of your oil to generate the combustible gases. Usually they do it. Now they start to do this one. Usually they do stray gassing for the new oil, but now they also start to do it for the used oil and surface, because stray gassing or creating generating the gas depends on the composition of the oil. If there is aromatic or not, less aromatic, high aromatic is affected. Oil with high aromatic, it has a capability to absorb the gases, but with very low aromatic, it can release the gas bubbles. But the problem also, you cannot go very high in the aromatic percentage, but there is an optimized aromatic percentage. I think so. It's around 8%. I think so. Gassing tendency. Also, this one, there is an instrument to check also another system to check your gas to the creating the gases. But this one, it's a little different, using the pressure, using everything, or exact the same situation as the transformer. This is what you need for the DJ. Now, evaluation of the gases. There are many methods, diagnose methods. Usually we, or for myself, or we, some team here, we try to use our knowledge and experience. And then after that one, we go to the diagnose method, like Duval triangle, or there is also, there is 3 ratio, there is 4 ratio methods, there are many methods. There's Duval triangle here. Triangle maybe here, give me a little very short information about if you have partial discharge, or if you have thermal fault or something like that, based on the ratio percentage of each gases. There is the new one now, it's called Duval Pentagon. This one is a new method, but here is better that they use more gases. Before they use 3 gases, here they use more gas and give more accurate to what you have for problem. We use this one when we, in the last time, just to compare with our knowledge and experience, if it is okay, to just try to cover all types of diagnosis method. I have some case studies here. Here I get one sample, I get for very high, the quotient limit, and for hydrogen it is 150. And here I get 436. And methane also get very high, something like this. And here equilibrium gas pressure is very high because it should be less than the atmospheric pressure. This is the atmospheric pressure, hecta, what's called Pascal, or 1 atmospheric, it's same thing. If it is more inside the transformer, if it is more than the outside, that means the possibility of generate the gas bubbles is very high. But here, if we see the evaluation, interpretation, the result here, we have something like this. Extremely high hydrogen and other fault gases in the oil indicate partial discharge. Partial discharge occur when the electrical field in a location area changed in such a way that location current is created. This information, we give it to the client we need them to also to reach them and the information, knowledge, that they understand what's meaning partial discharge, why it's very, very dangerous to have like this one. Also, equilibrium gas pressure here is written that the equilibrium gas pressure is attributed to high nitrogen. Of course, very high nitrogen here can give me also. So the equilibrium gas pressure is the total of the gas. And the recommendation in this case, we give them a new sample for DGA. This is recommended after 1 month to follow up fault gases. And of course, this one according to IEC standard 6599. Because increase 10% generation per month above typical concentration value is generally considered a prerequisite or critical for pronouncing the fault as active. This one should be take action direct for this one. If we bring it after 1 month and it was 10% more, that means now the time to take action direct. You cannot wait more, otherwise you will face a critical problem in the later. Another case study here also. I remember it was very small transformer here, but we get very, very high, extremely high, and hydrogen. But after 1 week, I think we bring it, it was more than 50%, 60% increased for this one. And then direct after this one, we told them now the time to de-energize or stop, shut down the transformer. You need to do fault investigation, direct. They invite me, but and I check it. We found this one, the tap changer here, it was inside the oil of the transformer. It's not in the vessel. It's a small one, but inside it was the tap changer. And we found here that this one is broken here, and all the times give me spark from this. The spark here give me increase in the gas, in the gases. And this one, it seems like a partial discharge formation. And then I think after this one, they separate the partial the tap changer from the transformer. That's mean that oil analysis as a primary indication is very important, very, very important. I will take about paper degradation. Paper degradation is very important also. Of course, it's the main things. But what you need, which test you needed to evaluate the paper, insulating paper. The paper is actually, any paper is cellulose, is group of glucose parts. Of course, if there's overheating, oxygen, water, partial discharge, arcing, all this one affect about the paper and can damage the paper to be glucose. But usually the products of the degradation of the paper is furfural or furanic acid or furfural. This is 5, is written here furfural, but actually it is 5 compounds of furanic. And you'll get water, mostly CO. CO is the first key indication of the degradation of the paper. And you will get methanol. You must check also methanol here. This 3 things is very important. This gives me we can give the evaluation, accurate evaluation for the paper. See here, the paper is very bad, is damaged, and I remember it was around 50 or 60 dB value. dB value, what's dB value? dB value is the depolymerization number of the paper. The normal for a new one, it's around 1,000, between 800 and 1,200. So around 1,000 dB value. dB value depends on the glucose part of the paper. They calculate like this. Or the number of glucose in the. If we go back to this one, the number of glucose here should be around dB value around 1,000 for a new one. But dB value, it's also not, it's for unit by unit. It's not meaning 1,000 for all transformer by unit or paper. dB value here, we take it from the oil, we calculate it related to two foranic, one of the four. So there's an equation between them. There is a method, international methods, many equations, but we use one equation. We think that is okay. This one is called indirect dB value, but there is a direct dB value. That's in the critical case, we take around 20 centimeter of the paper, which is suspected that there's a problem with it. We take it in the lab and we do the test, 3 or 4 tests, and to give exactly the dB value. The dB value, from the dB value, we calculate the lifetime remaining. How many years remaining for the insulating paper? Of course, how many years for insulating paper? This one give me information how many years remaining for your transformer. So from this one, we can give you information about the lifetime of your transformer. What you need, test you needed to evaluate, to accurate evaluation of the paper. Of course, the 4 is 5, but the most important actually is this one. Usually it's coming it's coming like this, and then very big, then like this. So this one 4 is number 2 in the instrument chromatogram. dB value indirect using value of 2 for 4. CO and CO2 from DGA test, we can take it, but mostly this CO. Methanol test, dB value direct, and the critical case we can do it, of course, or the labs they can do it. Transformer lifetime remaining by years is very important to you. We'll go to oxidation deposit. It is it's important here to understand it. I don't want to keep you in to see all this the chemistry compounds, but this one from one article, I took it from one article, new article, this one, not new, but it is a new information was in that time. Because before we see that oxidation deposit, the oxidation process can produce acids and water, but actually it can produce more than this one, because the stage of hydrocarbon, see oxygen, see oxygen here, attacked and overheating, of course, attack the hydrocarbons, the oil, this is oil, and then produce peroxide, this one, very important to check it. Reduce alcohol, but alcohol is difficult to check it because very light one. Also aldehyde, we cannot do it, or we can do it by a special method. Acids, you need acids. And you need to see the ester, because ester is the last stage of the oxidation. So if you have only peroxide and you have zero or nothing from the other, you have only peroxide, that means the oxidation is start with you. That means be careful that you must consider that maybe you will get an oxidation. In this case, we recommend to add an antioxidant if you haven't. If you come to organic or to the acids, in this case, if you have high acids, more than Cauchy limit, that meaning you are mostly in the oxidation last stage. But if you have ester, that means you already have a problem on the paper. You have some. Usually this one come with the sludge also. So you have a problem. Therefore, you must preventive maintenance. We must from beginning tell you that your problem start. Now you must take action. Now you must do something. We try to make preventive maintenance in a correct way, that when you can decide to take action is very important for you also to now what's the process now, what can I do now to stop this fault or oxidation. If you see here, there's oxidation deposit on the winding, but this one, it is for the tap changers. Also on this one, see how it looks like. This one prevent the heat exchange with the oil, reduce ability of electrical insulating system, accelerate aging of insulating paper. And one time I get formation sludge. One time I get here, I think this video film also. One time I get here sludge in the oil coming to the lab. If you see the sludge, this one the sludge. This one, that means you already have oxidation deposit on your transformer. Static electrification phenomenon. There is now some transformers failures due to static electrification. What's meaning this one? Meaning that with the time, the oil is in the circulation system all the times, and this one with the long time, the charge positive and negative, it will accumulate in a different position or location. This one will give a problem because it will be charged between them also. Having charge, it's called static charge, flash or charge, static flash or something like that. This one, in some cases, if the oil insulation system if the insulation capability of the oil is very low, it can be a problem, a real problem it can be. The friction between the oil and the salt, high level of localized electrostatic charge, it can be. And this over voltage could trigger a sequence of electrical discharge and arcing at low voltage, but it can be affected. It can be failure, trip, or something like this. So this one also we need to take care about this one. Consider this one. There's a test, electrostatic test for the oil to see if your oil have capability to do this type, because this one also according to the quality of your oil. What can be also this another information for static that moisture content can affect temperature, high temperature, of course, flow rate, especially it's happened with the transformer, with the pump. The flow rate can also affect for this one. Test for oxidation, it is around 22, but it's not all you can do it. You can take the regular test, but this one cover all the situation of oxidation: acidity, peroxide, water, ester, sedimental sludge, bromine number. Bromine number, it is to see how it's the polymerization of your oil. Interfacial tension is a physical test to give me information. If you have this one, that means extremely high, that means interfacial tension it will be very low. Give me indication that there is oxidation. Breakdown voltage also, this usually, or most of them, they use it. Breakdown voltage also give me information if you have oxidation products, if you have conduct particles or something like that. Power factor also is important, that give me if you have elements, if you have copper ion, if you have iron ions in the which they are usually from the core, and from iron from the core, and copper from iron from the winding. If it is in the oil, this one can affect the oscillation of the oil actually. And the power factor give me information. Very high power factor, that means you have metals, ions in your transformer. One special case, we get power factor very high, and we didn't find copper and iron. Then we did that. We must see all the around 20 metals. We found silica ion, extremely high silica ion. Silica ion is very important also to check it, because if you have silica ion and you have oxygen, silica ion, and with oxygen, it will be silica oxide. And silica oxide is the component, it's called sand, the sand. So if you have, it will come in sand in your, so sometimes you find sand in your transformer. From where coming sand inside the oil? It's coming from silica ion. And from where can coming silica ion? In some cases, some transformers, they have a percentage of silica, very small amount of silica in the core. In the core, I think 5%, 3% silica in the core component. So this one must be take care. We all the times try to recommend the client about these problems. Oxidation stability, that also is very important. We take the oil with 1 week, 1 month to see under high pressure, high temperature, everything, just to see what can give me oxidation products. And additives, you must see if you have additives, antioxidant or not. Particle counts, you need density, color, oil fingerprint is also important to see how it is. I will talk about oil fingerprint. Relative content, also this one give me information about what you have. Oxidation product. Refractive index give me the aromatics. Flash point, of course, is very important. Viscosity, aromatic content, you need it. Carbon composition, aromatic, naphthenic, which type of your oil. Electrostatic charge density, what we talked about, static fault or phenomenon. So this one gives me information that your oil capability of your oil to do this static. This one and the corrosion deposit, this is the last one, I think, corrosion deposit. Now the problem now, most of the transformer, most of the fault in the transformer can be due, or not most, some of the transformer now due to corrosion deposit. From where can be corrosion deposit? This one, we did research actually for this one with King Fahd University and with Linnaeus University in Sweden. And we get very, very important result for this one. We found from where can be this one and how to solve it also. This is one of the corrosion deposit. If you see, it is cover the winding here and here oil or winding. So there is no heat exchange between the winding and oil and the heat all the time, the heating in the winding. So it will be a problem. In one of the article when we start 2017, this I get permission from Aramco to publish this one in articles. In the Aramco, we found that they have there is some problem with the corrosion, but in that time we didn't know exact what's kind of problems or how it's happened like this. They get damaged, and then in the winding, then we took one we cut something here and winding, and we did it's called SIM instrument to see. We found that 5% sulfur was. This one indication that this one due to sulfur corrosion, sulfur deposit on the transformer. After that one, we start to see what's the problem, how we solve it, and we get cooperation with King Fahd University, Aramco, and Linnaeus University. We studied this research. It took around 2-3 years. We published many articles about this one. For this problem, we get patent because we need to see what's happened chemicals inside it from the glass. We not to see what's happened. So we get a patent for this one, and we start work on this to see what can get the products, chemicals or gases after deposit. This information, it was no information before about this. Before we do just DBTS, sulfur compounds. We just check sulfur compounds. But this one it's not, I will show you that is not correct just to see DBTS. This one, it was one of the, also this video film, I think. Sorry. What's happening here? Okay, I can't do it. I'll back again. You see here? We took the oil here after. We kept 1 week, I think, and we took the oil and checked the oil before and after. and we checked the oil before and after. What we found in that study, of course, I mean, it's not just one time. We took many analyses to be sure that it's correct. We found that presence of DBDS, presence of DBDS, dibenzyl disulfide, is the main source of the corrosion, is the main one. There is many other sulfur, but this one is the main. The other is not affected too much, but this one is the main one. Why? Because this one with usually DBDS is antioxidant, actually. If you have DBDS, no need to add an antioxidant because it is antioxidant. But this one, DBDS already from the beginning, from the oil manufacturing, there is, from the crude oil, there is the sulfur inside. But the problem with DBDS, it's with the temperature, high temperature, overheating, it can be converted to another sulfur. It's called benzyl mercaptan. This mercaptan is very active. It's not stable. DBDS is stable, but this is not stable. Searching all the times in the oil, searching on the copper ion. If he found copper ion, so it will be direct to the copper sulfide deposit. So, and we found that after deposit, it will come H2S gas. It will come toluene also, but the mostly coming H2S gas. So therefore, to check all this one is very important. Give me information. Because DBDS with the time is reduced because it's used in the corrosion process. So this one to be reduced. And after 10 years, maybe you will not find DBDS in the oil. So if we do just DBDS, you will see you haven't DBDS. It's okay. We haven't a problem of because you haven't historical data. You haven't a problem. You say yes, it's okay now. I'm okay. My transform okay, but it's not correct. You need historical data. If you have from beginning and now after 10 years 0, that means it's consumed in the corrosion. Maybe not corrosion, maybe it's consumed to mercaptan. But if any time copper ion appear in the oil, that means you have corrosion. So you need to do all this test. Effect of corrosion sulfur, of course, increase dielectric loss when the thermoelectric induced electrical ferrous metals sulfide are conductive. By the way, this one is conductive. Copper sulfide is not conductive, semiconductive. And semiconductive in the can be reduced. There is, since metal sulfide are conductive or semiconductive, the dielectric breakdown strength of insulating paper is reduced and the result arc between 2 or more turns of the winding. Degree efficiency of heat exchange, of course, as normal. Degradation of insulating paper. And what you need is to control your corrosion. DBDS, of course. Total sulfur mercaptan you need it as a total. Hydrogen sulfide gas, mercaptan you need also as a gas. Toluene, copper ion, benzyl mercaptan, basivator, if you use basivator anti-corrosion or not. Corrosive sulfur test, this corrosion. This is also important that we take the oil and keep inside the copper ion and we keep it in the oven for 3 days at 150 degrees and see if it's corrosive or not. This is very important also. Total sulfur content give me quality of the oil. I will come to 2, 3. I think this maybe 2, 3 slides remaining. Oil fingerprint is very important sometimes to see what type of your oil. If there is mixing of two oils, we can give you exactly what type of your oil. This is Nitro Libra, Diala. This one fingerprint. So we can tell you what you have, which type of oil you have. Another thing is particle counts. Also is important to see if you have a particles in your transformer. This one also is good to have it in your oil. Recommendation. What you need, what's the solution for these faults, sorry. First one is minimize oxidation process by adding antioxidant, butyl hydroxytoluene as normal to the oil. And this one you need also to check it every year to see if you consume, I think around 0.4% or 4.5% is recommended. But you must check it every year to see if it is reduced, so you need to add it to the optimized level. Minimize corrosion process by adding anti-corrosion, passive factor, RIGMA BTS or RIGMA BTA or RIGMA 39, according to what you have. This one, okay, but for corrosion to close the corrosion problem, you need to remove DBDS if you have. Remove DBDS, you can do by many methods, but we prefer this method. Mobile, it's called depolarization technology. It's very good that can take it in very short time. And it can take not just DBDS, it can take also polar substance like peroxide, like all this one, acids, dissolved gases, water, sludge, PCB, all this can remove it by maybe it took 2 weeks or something like this. It's very good to remove DBDS. There is another method also, but we think from chemistry side, we think this one is good. Oil filtration, sometimes we recommend to remove if you have gases or water and particles. Or oil regeneration team to remove dissolved gas, acid, water, and other contaminants. But this one, oil regeneration will not remove DBDS. You remove this one, oxidation product. This one, what we recommend for the client. Thank you very much. This is my email, my mobile. You can write this one if you need any information, anytime. If you need to send you the articles, which we have, and also any question you have a problem, just call me and send me email. I am ready for anything you needed. Thank you very much. And I open now for any discussion or any question.
Thank you, Dr. Ramzi, for affirmative presentation and this value experience. Let us now open the session for any question, any query of all attendees who can raise his hand for any question. Mr. Ramesh. Welcome, Mr. Ramesh.
Thank you, Dr. Ramzi, for the wonderful presentation and very good information. And it's nice to see some of my ex-colleagues on this platform. I would like to ask you a couple of questions.
Yes.
First of all, as you mentioned about static electrification, which is an important phenomena, So
Yes.
how to detect static electrification in my in-service transformer?
Yeah, good. See, usually there is a test by using conductivity method. We have a test like this, conductivity. We check the conductivity of the oil, and from the conductivity we can relate it. We can see if your oil have capability for static. But direct, we cannot tell you you have static. We tell you that now you must be careful that maybe you have a static. And this one is very easy test and it will not take time. Just tell you that this information. But I forget to say that for static solution for the static, I not written. Maybe I forget to write this one. It is mostly the passivator, anti-corrosion. It's anti-static also. Let's call it. If you added anti-corrosion, you will because it is also anti-static. So you must add it anti-static. Many companies they use a passivator for both sides. But direct, I cannot. You have now static. I tell you that the oil have very high capability to do it. So, and also we must take it also by another side that it is not just this information. We must also link to the what type, your oil quality of your oil. What's if you have oxidation products, if you have some other, all this one is affected about. If you have too much high water, all this one will tell you now 90% you have static. Or maybe you will have static, but this according to all tests together, we must check it.
Thank you. But what are the triggering points? Like, for example, we are monitoring more than 1,400 transformers. So what are the triggering point when I should check for the static electrification? Basically, we are doing DGA routine test and other oil quality test for all our transformers. So
Yeah.
What should be the triggering point? Like I should decide to check for the static electrification for some of the transformers.
Yes, usually 1 year, every year, annually is okay. But also we must see type of your oil, condition of your oil, all this will affect. But the standard is annually. Each year you should do it.
No, you mean I should do annually for all my transformers or only for some transformers where I find problems related to oil quality?
You mean by another thing? You talk now about the static phenomena or
Electrification. Yes.
all?
Yeah. See, for our transformers, we are doing DGA and oil quality test. But for static electrification, do I need to do specific test for all my transformers, or only if I find some issues in my oil quality test, then only I should go to check static electrification?
See, because you haven't historical data. I think you haven't historical data for static.
Yeah, we have historical data of over more than last 10 years.
Yeah. So we recommend to do it first, do scanner for all your transformer because it's very easy test and it's not take time. First, do it for all your transformer, keep it at historical data. Then from this one, you can see if it will increase or not. I mean, maybe you have static, you get some static, small static, but that's not meaning your transformer will have a failure or something like this. But we must follow this one every year. If it is increased or stable, if it is increased, that means you have a critical case. This one we must focus on. So with 2-3 years, then you know that some transformer, they have a problem with static, so focus only for this transformers. Like this one, it's happening. But because you haven't any historical data in the beginning, do it scanner for all. Then from this one, we'll see separate some transformer which focus on some transformer for static.
So which test are you recommending?
What?
Which test do you recommend for static electrification?
Electrostatic test. It's called electrostatic. It's by conductivity method. Electrostatic, but it will not take time, and it is direct coming the reading.
Okay. If you have some
is need around 200 mil, just 150 mil, something like this.
Okay. Thank you for this very good information.
Thank you. Thank you for it. Any more questions?
Mr. Ramsey, good afternoon. This is Praveen from Ray International. We talked about acetylene. By looking into the acetylene value, is it possible to distinguish arcing from the winding or from OLTC?
I couldn't hear you very well. You talking about acetylene?
Yes. See, acetylene indicates arcing in the transformer. But is it possible to distinguish whether the arcing is from transformer winding or from OLTC?
You mean acetylene? See, acetylene, of course, it's coming for the if there's a very high temperature, mostly from the partial discharge arcing, mostly from the arcing. But sometimes what's happened? Sometimes I think one transformer from Kuwait, I think was, we found extremely high acetylene, but we didn't find any other gases. So there was the most thing I thought about this was that there is a tap changer. So maybe there is a leak between tap changer and the oil of tap changer and oil of the, so coming acetylene to the, and when we, and it was increased too much. Then when they open it, we found there is a leak. We found extreme, first we found extreme, first I ordered for, I requested them to give me oil from the tap changer. We found extremely high acetylene. So the most things that it can be is leak from the tap changer to the oil of, if it is just only acetylene. Something that it happened with us like this, because normally acetylene is coming with hydrogen, a little from other small other gas, but mostly coming with hydrogen. I think I answered your question, or because I didn't hear very well what you said.
Yeah, fine, noted. So could you advise us what is the acceptable value of acetylene in a power transformer?
Okay. Critical acetylene is according to what you have from standard guideline standard. Usually in our lab, we use IEC standard 6599. And this one, every year they have a version. This year, the version was maximum 50, I think, 50 ppm.
Okay, thank you.
Or 20 or 50 ppm, according to the standard. I think 50 ppm was the maximum. I can see in this presentation, I have one, I think I have one. It's written here, maybe. Here. Acetylene 20, sorry, 20. Maximum 20. And this according to IEC standard 599/2022. The last version, it's 20. The maximum 120, because the problem that acetylene is coming with very, very high. Usually acetylene is like this, CH, like this. And it's very difficult to break the 3 point is need extremely high temperature to break this one, to coming sorry, not to break, to form this 3 bonds. Where the other is just C1C is easy to generate. Therefore, they keep it very, very low, because 20, more than 20, that means you have extremely high temperature, arcing or partial discharge at high volts, which can form this type of acetylene. So should we consider acetylene is very, very important to check to see the quotient limit of it. I think I also forget to say something that in one of research. Now you said you see I have one research or one articles I have to see. Now you are waiting from the lab to tell you that it is 25 ppm acetylene, you have a problem. But if it is 19, you haven't a problem. This is not correct. See, this one, the limit, they do it on the 1000 transformer, something like this. Research, they keep this 20. This is not fixed. Usually, if it is 19, I see is very dangerous. I mean, this figure is not example. What we found, we have equation in the one article to tell you now you have a problem. It is not a 20, it is something before. Yeah. It is around 80% or something like this before this special equation. There is equation, we found it, we have it in our lab. We use it to tell you, even if it is less than quotient limit, we will tell you take action. Now take action. Therefore, when we say exact, this is the problem. You said 19, I said 18, another said 20, but this equation gives me for all, they must follow this one, when you should take action. I think it should be in this one slide, but I didn't find in this slide. There is calculation for I think there is, yes, I will show you now. There is a calculation for this one. I think I kept in the corrosion. Anyway, if you want, you have my email now. Just send me. I will send you the calculation and the I didn't find now. I can send you the calculation and the articles of this one. But usually it is near to quotient limit. We direct and recommend the client to take action. Any more question?
I have one question on oxidation deposits.
Oxidation deposit, yes.
Yeah, as you mentioned that the presence of ester is very critical for the oxidation deposits.
Yes.
So for routine, for oil test, we are doing a particle test, sediment and sludge test, and other oil tests. So do you think this is should be a baseline for detecting oxidation deposits? In case of any observation of sediment and sludge, then we should go for further test to detect presence of ester.
Yes, but the problem is that you should not wait until you have a sludge. Usually when we recommend ester, if we see there is the acid, high acid, with the high acid, if you have a high acid, we recommend you to take ester. But the problem is that also we have another problem. Because the acid, some of them convert to ester. So sometimes you have acid normal in the normal case, if you haven't historical data. Sometimes you have in the normal case, but you haven't any information about ester. So maybe this loss of the acid is converted to ester. So this one, you are in the critical way. So this is the problem, that we need to know this one as historical data with you, as ester. But yes.
For example, my oil test, the acidity of oil is within the normal limit, and
Yes.
the other results of particles and sediment sludge is also within the acceptable limit. So shall I consider that the oxidation deposits are not there and the transformer is free from ester?
This one, the classic things in the now in this area, that you see that you have example 0.02 acids, which is in the normal way, and you have the other thing. Okay, you have 0.02, but you don't know the series of the reactions here. Maybe, and maybe not, of course. Maybe you have loss of some acids if you haven't any history. If you some acid to sludge, so you cannot see your acid. You see just a little acid, and also some peroxide. You have 0.02 acid, but you have extremely high peroxide. That's meaning the reaction in the way to you to be more acids in the way. The reaction, by the way, this one is not by 1 minute, 2 minutes. This reaction take maybe 3, 4, 5 years. We don't know. This is not very fast, very, very slow reaction, but in the future it can be. Therefore, if you have good acid, not good acid, low acid, and the other things, particles, everything sludge, everything okay, maybe you haven't like this, but be careful that maybe you will get this one. Maybe you will get ester, because the time between acid and ester, it's long time. It's low, it's a very low, long, it was very slow reaction to be here. Therefore, it is now, until now, it is not main test ester. It's not the main. The main is acids. But the acids, the problem, if you have high acid, is good to tell you that now do oil regeneration. Why we tell you now do oil regeneration? Oil regeneration. Because until now, you have not deposit. So do oil regeneration to remove the acids from the oil. But if you have oxidation deposit, there's no solution. If you have deposit of oxidation, there's no solution. The first solution, you rewinding. But our task, we tell you that before the fault, we tell you take action now before you get to the problem. So therefore, I think so. It should be this ester. It should be a new things to be used in the evaluation of oxidation. But that's not meaning the main one. The main one is the acid here. But this one give me more information, but the main one for you is the acid. More the acid, we tell you that do now direct oil regeneration in the next maintenance plan.
Yeah, thank you. I think this is good information, but somehow it is not included in IC 60422. I think only it says about acidity currently.
Yes. This is new information. This is a new. Yeah. Therefore, I told you this is a new information from the chemistry side. We have this information, but this one, see, now it's coming more and more research. It will be later. They keep it in. How they keep this test in the standard? How they see all the new research talking about something, they keep it. But this one, as logically, this one is correct, logically. But still now there is no standard to you to do Easter.
Yeah.
Or
Okay.
to do peroxide. But this one give you information that where are you, in which process, in which stage you are in the oxidation. This is extra information. But I think it will come. It will take some time. It will be, I think so.
Okay. Thank you. Regarding the DG of cable box, we see transformer main
cable
tank
box.
DGA, we have standard limits in IEC 60599. But is there any limit available for transformer cable boxes?
See,
Because as in IEC 60599, there is no specific information about cable boxes.
Exactly. The standard of this one, there you will not find. But this cable box, the oil inside, the mineral oil inside cable box is linked with the tank mostly, because I think so. The cable box, between cable box and the tank, there is a valve to switch off or something like this to separate. But usually it's used the same. So sometimes what I found, we in our lab we use the same limit as the mineral tank. But what I find sometimes extremely high, example, hydrogen in the tank, and we will do cable box. All cable boxes, we found same things, very high hydrogen. Therefore, I asked the client, do you have open or closed the link between cable box and tank? If it is open, that meaning this is coming from the tank. You haven't any problem in the cable. The problem already in the tank, not in your cable box. But if it's closed, that means they have a problem with the cable box. Therefore, we cannot do just cable box alone. We must see it, compare it, or take it also consider the oil in the tank between them. That one we can recommend what he will do. Mostly, but if the gases in the tank is normal, nothing, and we found high hydrogen example in the cable box, yes, now you have problem in the cable box.
But in this kind of scenario, normally we have a separate cable boxes where
Yes.
the main tank DGA dissolved gases are fine, no hydrogen. But in cable boxes, if the hydrogen value is very high, so there is a counter argument that it is because of stray gassing.
Yes, that you have problem in the cable.
Yes. So, but how to differentiate whether it is a stray gassing or it's a real problem of partial discharge?
Real problem if we found that it's extremely high hydrogen.
Yeah, extremely high. Like some cases it is in 2000, 3000 ppm.
This is extremely high. In this case, you have overheating in the cable. You have overheating in the cable. You must find a solution for this one.
We did some study, and actually those cable boxes are kept under close monitoring. But we got some counter response from the manufacturer that it is stray gassing and not the partial discharge.
Because sometimes also, I didn't face like this problem, but I face a problem with transformer in Saudi here, one client. And he has also all the times hydrogen, and the hydrogen by thousands, and every day coming extremely high. Then I told him, no, stop, now you must de-energize. There is a problem, you have a rectified problem. And when they found it, when they opened it, I was with them. We didn't find anything. There is no problem. Everything. They did electrical testing, everything. Okay. Do you know where the problem we found it? The earth line, there is something screw or something like this. It was open loose, and this one gives spark all the times. So something is you cannot think about this one. But it happened. Some screw, something, maybe this connection in the cable box between the connection and the it was not very, there's some loose, something like that. Maybe. But as I told you, sometimes you open the unit and you didn't find any problem in that, but still the problem. That means there is something. One time also we found that new transformer and they have a problem with or the overheating, that we found that later when they did the investigation, they found that the lamination sheet was not correct manufactured. And sometimes we found also some you cannot imagine that transformer, a new transformer, and before energize, we did the oil analysis. We found extremely high hydrogen. From where coming this one? We didn't. Then when we see the, we found that there is a high moisture inside. The high moisture with the iron in the core, together this one, the reaction, chemical reaction, give me hydrogen.
Okay.
So in your case, I think if I think about this one, there is maybe something in the connection, self-connection. I don't know. I must see you.
Yeah, actually, we have kept under monitoring, and we are also in consultation with the manufacturer for some of the transformers.
Okay. Manufacturing also very important to see the design of them is good or not.
Yes. Yeah. Thank you very much.
Just to add to this point regarding the cable box oil analysis, it is very important to know that the type of bushing that you have inside the cable box, if it is an oil communicating bushing or not. If it is oil communicating bushing, then the oil between the main tank and the cable box is communicating together. This is a very important point. Even if you have a separation in the conservator tank and the piping. I found that the cable box oil analysis is very important and very effective. We had a case study where we had already flashed over bushing or starting of a flash over actually inside the cable box. And we got the high acetylene and high hydrogen inside the cable box. And by that oil analysis, we took the transformer out of service, opened the cable box, and we really found that the bushing is already start to flash over. And we replaced the bushing before before a total failure of that bushing. We could lose the transformer, full transformer, if that bushing had a failure, and a flashover. So don't underestimate availability of gases inside the cable box. If you have gases, then immediately take the transformer out and open the cable box. Inspection of a cable box will not take more than 1 day. Just drain the oil, open the cover, inspect the cable box, and find the fault. It's much easier than inspecting a main tank of a transformer. So even if you involve the manufacturer, I don't recommend to wait further until the manufacturer give you a final recommendation. Go ahead and inspect your cable box.
Actually, we did inspection of some of the cable boxes. In fact, we also replaced the insulation supports available inside the cable boxes. And after replacement also, other than insulation support replacement, there was no visual abnormalities were observed. And after re-energizing the transformer, still the trend of some of the transformers cable boxes are still high. So that is the question. So we have kept under observation.
Check your bushing type. Most probably it is an oil communicating bushing, and the gas is coming from the main tank.
But the main tank DGA is absolutely fine. There is no abnormality.
What about your conservator? Is it a sealed type?
Yeah, it's a sealed type.
Did you check the oil and the pusher?
Did you replace the full oil of the cable box?
Yes, we replace the full oil.
Okay.
Okay. Keep monitoring the trends of these gases. If you see an increase, then most probably you have a discharge inside this cable box. You have to find from where the discharge is coming. If you have a testing tab on those bushings, check the testing tab as well. The cap of the testing tab, if it is open or loose, check it.
No, actually, there is no external testing tab. In fact, we did partial discharge measurement from the cable box externally, and we have kept those cable boxes under further monitoring after this actions taken from us and with manufacturer basically.
Okay. So better to keep monitoring on those cable boxes.
Yes. Yeah. Thank you.
Thank you. I have a question for Dr. Ramzi. Thank you for the informative presentation, Doctor. We have a lot of transformers with a thermal fault, which is exceeding 600 or 700 degrees Celsius, where the other gases are within the normal limits. And actually, there is no clear action what need to be done, especially for the thermal fault. If we have an arcing or a flashover or whatever inside the transformer, that action is clear to be taken. Yeah. But in thermal fault, where we have overheating, what is next if I have a thermal fault inside the transformer? What action needs to be taken actually? This question is still in my mind, keeping us in this question, and still we have a lot of transformers with a thermal fault, but we cannot take any further action.
Yes. In this case, what we recommend the client that to bring the samples frequently, after 1 month, after 3 months, frequently to see it. If there is any trend, gas trend or not. If there isn't any gas trend and stable all the time, that means it was happened before, partial discharge or something low voltage, and you get this gases accumulate in the. You get the gas accumulate in the oil, and in this case, I usually recommend the client to in the next maintenance plan do oil filtration to remove the fault gases, because already this is stable, and it's happened one time that some fault, and now it's okay, there is no fault. But if there is a trend in the gases all the time, that means you have a fault, or we call it the low volt partial discharge in your transformer. So you must do electrical testing to find where it is and what is the problem, something like this. This one, mostly we recommend the client about this one.
Okay,
But
clear.
the problem that if you have hydrogen extremely high, you cannot wait.
Last 4 minutes.
I would like to share our experience just regarding
Mr.
this point.
We have just 4 minutes.
Okay. If we have time, I would like to share my experience on this point.
Okay.
Actually, regarding the question from Mr. Tariq about increasing gases, like I believe you are having high ethane, methane, and ethylene. Is it correct?
Yes, correct. Acetylene is not there sometimes.
Yes, correct.
But
so
the overheating gases are available.
Correct. Yeah. So in thermal fault, basically you will not find acetylene, but mainly you will find methane, ethane, and some ethylene.
Yes.
So
Exactly.
we had similar issue, and we were monitoring those transformers. And over a period of time, while the gas trends were increasing, we decided to switch off the transformer, and we opened the transformer also. So typically, we
Okay.
found two types of problems in those transformers. The first one, it was a shell type transformer, and we found there was a problem in the bushing leads. There is a lugs termination from bushing leads going to tape changer and all HV and LV bushings. So the connection at the lugs was loose basically. So it was required to reconnect it properly. So there was a hotspot at the joints, basically you can say joints at the lugs. That was the first problem. And second problem we observed in other transformer was about core lamination was touching to frame. So there was a discharge at that area. So these two types of problems we observed.
Yeah, but
Oh.
this very good information of the gases, right?
Yes, from the trend of gases.
Yeah, from the trend. So therefore, Mr. Tariq, we need to do it frequently, this one, to see if it is increased or not.
Clear. Thank you, Doctor. Thank you, Ragesh.
And increase
Welcome.
should be not more than 10% per month.
Okay, clear. Thank you very much. Thank you.
Thank you. Thank you.
Thank you.
Thank you for all. Thank you.
Thank you
And
for all. Thank you.
You have my email. Anything question you can send to.
Sure. Thank you very much.
Thank you for all. Thank you for Dr. Ramzi. And at the end of this value webinar, let us seize this chance to invite all the attendees to participate us and join us to the upcoming conference, which will be held in on 13 to 15 November in this year in Abu Dhabi, UAE. So hope to see you there soon, inshallah. And thank you for all. Thank you, Dr. Ramzi.
Thank you for it. Thank you.